Assalamualaikum and hi everyone. I am Muhammad Nasri bin Nasir Khan from Group 20. So today we are going to do experiment regarding field density test. So I hope that you all will enjoy the video. Thank you very much.
Set up apparatus and record the measuring diameter and height of the calibrating container. The diameter of paper box hole. Weigh the mass of tray. Put in the cylinder cone in the tray and open up the valve and let the sand fall down. Close valve and weigh that mass. Record weigh the mass of cone cylinder with sand before pouring, then put it on calibrating container and let the sand fall down. Then, record the mass of sand and cylinder after pour. First weigh the mass of sand before. Place the paper box on a flat surface and using a hammer and chisel, dig a hole to a sufficient depth. Collect all the excavated wet soil into the plastic bag. Fill the cylinder with sand. Then, put the cylinder cone on the hole and open up the valve and let the sand fall down. Close valve and collect the remaining sand into the plastic again. Put in the excess sand on the cylinder cone into another plastic. Weigh and record the mass of wet soil dug in the tray.
Okay, our second experiment is the field density test. In this procedure, we have about a few procedures. Which is first we need to calibrate the calibrating container and the cylinder measuring cylinder. For part A, we do it in the lab usually, but due to some circumstance that we need to use our own laboratory equipment. So first we need to measure the mass offset in the cylinder cone, the small cone. And then we measure the difference between the mass after the flow and mass before flow from the measuring cylinder. And then we have the second part, which is field density. We did it at the test site. This is to measure the mass wet soil from the hole. We pick a place and then we dig a hole according to the diameter of our calibrating container for about 10 cm. Yes. And then we excavate it and replace it using the sand. We also need to determine the mass of sand before pouring and after pouring. And then we determine the ratio. And then for the third part is the moisture content. We take a soil sample and dry it and then measure the water loss. And then we need to find a specific dry density from lab compression that we get from any book, which is commonly used, such as that we get is 2.13 milligram per meter cube. So we find the dry density ratio from the maximum dry density lab compression. Okay, thank you.
So Izam, can you tell us about the overall values that you got from the experiment?
Okay, the dry density value of soil that we get from the test site is 1.53 megagram per meter cube, and we compare it with the maximum dry density from the lab compression that we get from the book, which is maximum 2.13 megagram per meter cube. We used some ratio and then we get the 70%, 71.8% for actual over theoretical. That's all. Thank you.
Okay, from the result for the bulk density that we obtain is around 1.53 megagram over meter cube. Based on the value that we get, we can state that soil it can classify as clay type soil. Then for the maximum dry density of clay soil based from lab compaction is 2.13 megagram over meter cube. Okay, based on the result obtained, the dry density ratio is equivalent to 71.8% with moisture content of 10.4%. For the field to be suitable for construction, it should achieve the dry density ratio between 90% to 95%. For the field soil to achieve desirable relative compaction, higher compaction effort is required and additional moisture should also be done. Okay, when the clay soil achieve optimum moisture content, the diffuse double layers around the clay particles will expand, increasing the repulsion between clay particles and give a lower degree of flocculation and a higher dry unit weight. However, if the moisture content lower, the density of the soil will expand the double layer of the clay particles, increasing the repulsion between the particles. However, this may lead to lower dry density of soil due to additional of water will dilute the concentration of soil solid per unit volume. So that's all.
Based on the experiment that have been conducted, from your point of view, how can we improve our values for this experiment?
Thanks, Nasri. Well, in my point of view, firstly, I think that it is essential for the surface of the ground is leveled, because we need to make sure that there is contact with the ground at the around the edges of the flange center hole. Then next is I think that we should fix the plate using nails, and we need to make sure that we push harder into the soil adjacent to the edge of the plate in order to avoid movement of the plate during the test. And I think we should make sure that all excavated soil or sample is placed in a proper container to avoid the moisture losses. And lastly, we need to check whether the sand used in this test is in dry condition, because it is vital to ensure that all the excavated soil has been transferred fully to the tray. And we need to also measure the whole excavated soil to obtain the accurate value of the bulk density of the soil. I think that if we follow some of these precautions, we can get accurate results.
Thank you, Azrin, for that explanation. Farina, can you summarize for us a little bit regarding this experiment?
So what I can conclude from this experiment as the objective for this experiment is to determine the density of the soil in the field by using the sand replacement method. So the result that we obtain for bulk density, moisture content, and dry density of the sample is 1.69 megameter cube, 10.9%, and 1.53 megameter cube. These parameters are important as they play a role in order to know whether the compacted soil is achieved the desired unit of compaction in the field. Therefore, the experiment objectives have been carried out and achieved.
Okay, thank you, Farina. So I guess that this site require more compaction if you want to make it as a site, as a construction on this site. So we need to have more compaction till we get the ratio of compaction about 90 to 95%. So guys, thank you for all. Thank you for having in the video. So that's all today, and we will see you again.